Thanks for the introduction. So, I'm Maarten, I work for Container Solutions. I'm on Twitter, GitHub, and I run the Rust and Nixos meetups. And I started out as a developer and noticed that the operations part was actually quite interesting and took a bit of a masochistic pleasure in trying to whip the servers into doing what they should do. And that turned into the whole cloud native stuff with Kubernetes and other interesting technologies that you can use to have a bit more confidence in how your production system actually works. So I don't know if this question has been asked. I was a bit late for the first introduction, but how many of you are doing Rust right now? Do we have new people? Okay, so who's doing Rust right now? And who's new to Rust? Okay, a few people. This is not going to be about Rust, unfortunately. This is going to be about Bazel. Although I think it's actually quite interesting to take this nice Rust thing that we have and put it a bit into context. We'll get back to this later. And in particular, I want to talk about build problems. So my agenda for today is to discuss some build troubles that I've seen, see how Bazel can help with them, and then do a live demo of Bazel so you can see it in action. In Rust, we have this very nice tool called Cargo. It has been, so far for me, maybe the most amazing experience with building software. And I was used to a bundler from Ruby, that's also pretty nice. But really, Cargo is just, it feels completely smooth and very finished and properly done. However, we always have some build troubles, especially when you build software that is not implemented purely in Rust. And then typically you grab for a nice makefile or a nice build.sh script, and then suddenly you find typing yourself make clean, make all over and over again, because what is it doing underneath there, right? You don't really know. And even worse, sometimes you have multiple build systems, like CMake, and then maybe you have a nice piece of Rust that you use in JavaScript. So first you cargo build that, and then with yarn build, you can build some JavaScript that links into your nicely exported C-compatible Rust library. That's not very nice. And you might say, well, build problems. We just create my build script, my build.sh, and that's fine. But there are some consequences of that, especially when you are going to check your colleague's PR request, and suddenly there is another tool, like Rebar for Erlang. What's that? Do I need to install more dependencies on my system? It's getting complicated really, really quickly, and it also takes more time. All these different build tools, and how do you know when something needs to be redone? You don't know. So that's why people keep running make clean, make all over and over again. So this really slows down your development process if you don't have your build system under control. I have had an interest in Bazel for a few years now. As I said, I run a Nix meetup, which is a bit like the Haskell of build systems. It's a very fundamentalistic way of looking at how to build software, which, just like Haskell, is an interesting perspective as well. But now we had a nice opportunity where we had a client that had some problems with their build system. In particular, their build took something like 15 minutes, which is longer than we would like, to say it at least, right? So we went over to the client for a few days, and we got back with that currently they don't trust their build. They will make clean, make all the time. It's way too long, 15 minutes, and it's actually pretty complex. No one really understands the top-level makefile that they have that then runs make in a subdirectory, which then runs a bash script, which then runs some JavaScript and whatnot. It's a mess. So we wanted to really start from getting rid of this no trust, because if you don't trust your build system, you keep running clean builds all the time, and that's really, really slow. So we want to have trust, and if you have trust, you can start caching things, which will speed up your builds. And hopefully, we can do it in a way that is a bit simple, so that you won't have to explain a very complicated thing like Haskell to your end users, right? So in general, it would be nice to have for these build systems one tool to rule them all that is fast and that you can just trust to do the right thing. And well, Google has a solution for that. Like for many things, you can search it. But yeah, I was thinking, let's find the logo, and I actually like this screenshot quite a bit. So Google builds all kinds of interesting infrastructure internally in their company, and not the least, they built Borg, this the internal orchestrator, that they then rebuilt and distributed as Kubernetes. And that's a really interesting idea of how to run software. You know, like don't have pets, run a few containers. If some of them die, it's cattle. You don't really care. They rebuilt Kubernetes from scratch, and for the build systems, they did something different. They took their internal tool called Blaze, but it was already apparently a patented name in software, and then it's a bit hard to reuse. So they just moved around the L to the end, and they ended up with Bazel, the build tool. And the motto of Bazel is, well, build systems in general, you want to do them fast and to correct, and typically the make clean is correct, and just the make is fast and it's wrong. And the punchline of Bazel is fast, correct, pick two. And that's a really nice way of looking at how to do build systems, right? You want both, basically. So how can Bazel help you achieve those goals? It does two things. First of all, it creates a directed acyclic graph, just like Terraform. If you type Terraform plan, for people that know maybe some infrastructure, it will compute what it needs to do, and you will get a dependency graph of all the things that depend on other things. Bazel is doing exactly the same. So there's actually a nice model in there that you know upfront what it is going to do, and you can expect that, you can look at it, you can even measure it and see where your bottlenecks really are. The next thing it helps with is that it can offload your build to a cluster of machines. That's the second part, the execution, and you can have a distributed cache. So for example, what you can do, but it's very nice, you can let your PR build on your CI system, and then if you, as a colleague, want to check it out, actually, you type Bazel make build, Bazel build locally, and it will just fetch all the artifacts from your CI system, so you will immediately start the binary instead of just building and building and building again. This is a nice picture of the direct acyclic graph, the DAG. I'm not going to talk about how to do caching or the remote building. There's a very, very nice, pretty long talk, 24 minutes, about how to do that. It's actually pretty impressive, where they show that they scale out to 1,000 CPUs, and your build is it just goes very fast. You can't really read what's going on. So I'm not going to do that. Take a look at that video later. It's really interesting. This is all the theory part I want to talk about. So let's get our hands dirty and do a little demo. Okay. So I had a nice Nest controller here that allowed me to do switching between slides and entering live coding stuff, but it's still in Amsterdam, so I'm going to improvise a bit. If you want to see it done properly with the Nest controller, come back to Amsterdam tomorrow. I will do the same talk again. So let's take a look at is this font size right? Too big? Too small? Too big. Too big. Okay. Still readable like this? Yes. Okay. So shout out if it's too small. I'm not going to clone. I don't know what the internet connection is here, but luckily I already did that. These are the examples of Bazel itself. And let's take a look at a very simple example of stage one. This is the hello world of Bazel, basically. And what you see here is that we have what we call a workspace. That's a directory with a workspace file. And we have the main package, just like in Go, Bazel considers directories to be packages, with a file, a build file. So this is a thing we can build, the main package. Yeah, the workspace file is not very interesting, it's empty. So it has some sensible defaults, but it's just a marker to not look up to parent directories, that this is the whole workspace that we are working in currently. I will show some more interesting workspaces later. And this is the C++ file, also bit simple. It's just a hello world program that prints a greeting and then prints the current time. And here we are at the meat of this example, the build file. And it declares a CCC binary rule with a name and some sources. By the way, maybe this syntax looks a bit familiar. Python, yes. That's because the language that we use to describe how builds look like is a subset, a proper subset of Python. So Google started out in prototyping this build tool in Python, and later they created a DSL called, it used to be called Starlark, and now it's Skylark or something like that. I don't remember. Something lark is the name of the DSL. The interesting part about this DSL is that, for example, you cannot open random files and read from them. So it's basically a functional programming language. It's a pure function that if you try to build this, it will always compute the same DAG. That makes it cacheable and usable, and etc., etc. So let's see what it does. I just ran something. I ran the C compiler to a C++ compiler to build this binary. And if I run it again, it is a no op, right? It takes 0.132 seconds. And the critical path actually doesn't take any time at all, because it doesn't need to do anything. Nothing changed, right? And if you take a look again what Bazel created, now we have a few extra files. And am I doing a find here? Just looking at what is outputted here, as you can see, the directory, the binary output directory is just a symlink somewhere deep inside my local cache directory that Bazel hijacked and puts the build artifacts. That's another nice thing of Bazel. Yeah, if I run it, then it does something. It doesn't really dirty your source code directory. So typically in C projects, you have these make files and they just litter object files all around. And that's just not very nice to work with, especially if you want to compile, to do cross-compilation or compile to different distros, for example. That gets hairy very quickly, so people start to do make clean, make all again, or they copy multiple of the repositories or have work trees, etc. It's getting messy pretty quickly. This needs to be a bit smaller. So let's take a look how we can extend Bazel. So in contrast to, for example, Terraform, that is a very, very small DSL, and that's why people actually resort to writing Python programs or whatnot programs around that to generate JSON that you can then consume with Terraform. Bazel itself is powerful enough to extend. And that's a very nice property. Yeah, going forwards. So for the client that we were working for, they had this big makefile and with all the small components in there that were triggered from this main makefile. And we wanted to provide a nice transition path. And one of the proof of concept we did for them was that, yes, we can break out of the isolation, how do you call it, the sandbox that Bazel creates for you. You can disable it, so you can actually do impure builds that still utilize some weird C compiler that you have in your system, for example. And that's nice because that was one of their worries, that they really had to convert everything in one go, basically. So let's take a look at this fake Redis example. It's a directory with a library here and a main program. And the makefile is just a boring typical makefile that you would use in a C project. And the Redis file just calls do Redis, which is not defined in this file. And the libredis thing just prints one line. And if we run make, then we build the separate targets and use GCC to link it to an executable. And as I said, the not nice thing about these workflows working is that you get a source tree that is littered with object files. And in this case, the client really wanted to build for different distributions that might link to, let's say, different versions of OpenSSL, etc. And they had to keep typing make clean, make all to get that to work, which took 50 minutes. So let's undo the damage that we did and see how Bazel would solve this. So this is a custom rule that I defined. It uses, the invocation looks just like any other rule. This is something that you would typically put in a different place in a support library that you can load. But this means that the local build redis.sh file, that's like my fake my build script that I'm going to invoke, will be made available to Redis, Bazel. And as you can see, I'm actually loading from this file, this build statement, this function, and then I can reuse it later. So this is basically importing into scope. And I'm just globbing everything that is under Redis, and the default is, this is like double negation. It's actually just getting the recursive content of the Redis directory in there. And the important thing is we need also to provide an output, right? So in this DAG, Redis, Bazel executes in two phases. The first one is the plan phase, where we just run this program, and then we should know the inputs and the outputs of every step. Those are hooked together, and then after this plan is made, we can see what we need to redo. If, for example, one of the files here in this glob is changed, then this output is invalidated, and everything that depends on this output is also invalidated, etc. So let's build it, and we can see that it does quite a bit of things. The not very nice things it does in there to break the sandbox, but in the end you see that indeed it copies the end result to a specific place that is expected by Bazel, so that information is made available within the rule. And this is probably going to, no, this is working still. If you take a look and then what's being generated, then no ugly object files, it's just the extra output that we saw before as well. And we can just run it, it's made available. So how is this actually implemented? How can we extend? This is the executed Bazel file that we loaded in our build file at the top level. And how do we define rules? Well, we say it's a rule, and the attributes that you can, basically arguments of the rule that you can put in, which is in this case source, the output, and a hidden build tool, which is the script I mentioned before, the build Redis script. And there is some implementation code that actually does all the work in there, and that's up here. And in particular, I wanted to show here, it doesn't really matter what it exactly does. This is valid Python code, right? This is a list comprehension, so you can do interesting computations in there. You can do some filtering, you can combine arguments, you can even do printf debugging. There's a print statement in there, very useful. So the point I want to make is that you can easily extend Bazel with your custom rules for different programming languages. You can, I said you couldn't read files, that's true, but sometimes you can cheat a bit and read some input, like a package.json file that you can ingest and use that to define more targets on demand. Another thing that is actually pretty cool about Bazel is that we have this DAG, and we can inspect it with some queries, such as getting all the dependencies of this fake Redis. And this is still kind of clear what it is supposed to do. It's just loading some C++ tooling and other support things that are in there. It might be interesting to visualize this. So there's also a graphics output. And if you would run this, then you would get this very nice picture that is not very understandable in the bottom part. But yes, this is our fake Redis that depends on the Redis directory and the Redis build script, which is depending on the build script itself, and some more tooling, just a small part of tooling, right? Yeah. So you can see all the gory details in there actually. So the funny thing about this introspection in this standard tooling is that there actually already exist some projects that use Bazel, and that makes it very easy to contribute to them because you don't need to spend ages and ages figuring out how to build stuff. It's the same everywhere. So let's take a look at Envoy, the Envoy proxy. Oh, I wanted to have a pause in there. This is the workspace of the Envoy project. So the Envoy project is a bit of a load balancer that is used by Istio, the service mesh that Google is pushing really, really hard. So if you have never heard about Istio, you probably will. Just like Kubernetes, that's old now. Istio is the new thing in the container, the cloud native world. And they use Bazel to actually build a product. Kubernetes too, by the way. And you can see here that they load some local, Bazel is a directory in Envoy, they load some stuff in there and they execute some rules that build more rules in there. Yeah, it's maybe a bit messy even what they do here because they have some constraints that I really wanted to use their existing, I think, CMake stuff as well. So the command I just ran, I'll just press arrow. Oh, I can't. Okay, the command I just ran was the same as before to show all the dependencies of, well, actually all the targets that are in there, and it works just the same. So that's a nice way, whatever programming language you would be using, if you would use a tool like Bazel, which can use multiple of those, you will just have a very nice way of interacting with that. And you can, just like I did before, you can still query dependencies of a specific target in there. But unfortunately, Bazel is not perfect. It failed. And even worse, it's an autoconf problem. Ooh, that's exactly the problem we didn't want to have, right? Yeah. No, not nice at all, right? It's still there. So, Bazel is a very nice tool, but the build sandbox by default, it's built for Google, and Google uses this big mono repo with all the tools in there. It's a relatively new tool, and although they have this very nice DAG, and the caching works phenomenal, and the distributed caching works just fine, the isolation is by default is not great, so you need to do some extra work to actually make sure that your compiler is in place, and that's the same problem we wanted to prevent in the first place, right? There are ways around that, but it's a bit tricky, and I need to investigate more how that works. So that's more for our next presentation, I guess. So thank you for your time. Before I am going to take questions, I would like to point you out to this domain. It contains a link that you can use to sign up for a Slack, how do you call them, workspaces. And yeah, take a look there. It might be nice to have a Dutch community of people that can ask each other questions in English, how to do Rust. Yeah. Questions? Yeah.
So, can you tell a bit about how the tooling currently supports cargo and C?
That's a good question, and I hope to answer that in detail for this presentation. Unfortunately, I'm busy buying a house, so I didn't get to the details of that. I know there is some tooling. It looks a bit hairy, to be honest. It looks like you need to run some code generator and then import that again, etc. So I use Nix, which is the fundamentalistic version of all of this, and you will never ever get this problem with the auto configure not being on my machine and might be on your machine because it's a bit more, how do you call it?
Rigorous.
Yes, a bit more rigorous about those things. And how we solve stuff there is that in principle, the cargo can be run deterministically. based on a specific version of the index. So what we do there is we specify the version of the index in the build description, and then the rest is a pure function, and that works. Might answer your question? Okay.
I was just about to ask, I was looking for how can you compare Nix to Bazel, and I know it's totally different, but I was just very curious if you see some.
I see some parallels and some differences. They both have this DAG in there. The difference with Nix is that it is definitely intended to be a package manager. So it works on the level of entire packages. And Bazel is definitely intended to build software. So during your day-to-day work, Bazel is nicer to work with, because in Nix, if you change one file, and typically then you need to recompile everything, right? That's a bit painful. However, you can combine the two, and that is what some people are doing, and that's very interesting. I can post a link on the meetup as well afterwards, that a blog post about how people make the compiler and all the libraries, etc., available, and then you run Bazel, both to build both within Nix and also in your development environment. But then you can't use, for example, the remote cache or the parallel execution runner. That's a bit more tricky, I think. Maybe you can still. I need to figure it out.
Okay, thanks.
Yeah.
I'd expect some pain involving keeping all the build artifacts around, in the sense
Yeah.
that you have limited disk space.
Yeah, you can store it on S3, so that's.
Yeah, but would that be very slow then, in that case, because you have to download everything all the time?
Only the first time.
Yeah. Okay.
But the key thing there is that they compute based on your sources and your build instructions. They compute a caching key, and then they see if it's there or not.
Yeah. So, and they prefer to schedule it on your local runner.
Yeah, there are some flags that you can configure, and there's a .bazel RC file that you can set up to work with a cluster of remote machines. Another thing that is interesting is that Google has actively 30 people working on this full time. Not just on the open source parts, mainly on the internal support tooling, but it's the same code that is running within Google actually. So my argument for should I run my own makefile or use Bazel? Well, do you have 30 people working on your makefile? Probably not.
Do you know something about?
Well, I also don't have 30 people working at Google, so.
Do you know something about the sandbox effect thing that they have?
That sounds interesting. I have not gotten it to work on my NixOS machine. So I played a bit with was it again the Docker isolation thing, but that didn't really work out yet. So as you can see, I'm mainly interested in learning more about Bazel myself. I just know a bit about what it is supposed to do, and we are about to start a project with the customer. So ask me in 2 months.
Yeah. So one of the maintainers of Bazel, I think, I'm not sure whether it's Bazel or Blaze, but they're working on a sandbox FS.
Yeah.
A fuse-based file system, and it used to be implemented in Go, but recently they've been re-implementing it in Bazel.
Ah, okay, interesting.
And it's had much better performance.
Of course.
For their sandboxing needs.
Yeah. Yeah. So for some context, the goal of this sandbox FS is to make available just the files that you need as inputs, and to prevent leaking input, so that you can't get more access to stuff that you haven't declared properly. Yeah. Okay. Thanks.